This is a video that will show you how to do Gibbs free energy calculations. So our learning target is that we're going to be able to calculate then whether or not a reaction will proceed spontaneously or not. So I just have two examples. This one is a reaction where you can take the iron ore, which we have in northern Minnesota, and convert it into iron, which can then further be used to produce steel and other metal alloys. So the question I have is, at 298 Kelvin, I know the enthalpy of the reaction and the entropy. So the question is this spontaneous or not? So we know we're going to be using this equation, delta G equals delta H minus T delta S. And I can just plug in my delta H, and then I have that temperature. Remember, it has to be in Kelvin, and it is. The only thing is, though, is my entropy, and this happens that they're given in joules per Kelvin, but you really need it in kilojoules per Kelvin, because then the Kelvin will cancel and you'll end up with 2 kilojoule terms. So I'll just do that down here, and a lot of you, I think, can just do this in your head, but I'll just show you that there would be 1,000 joules in 1 kilojoule, so those would cancel. So really you're just dividing by 1,000, so it becomes 0.610 kilojoules per Kelvin. So that's what I'm going to put here. So then my Kelvin cancel, and I end up with a kilojoule value minus another kilojoule value. And when I calculate this, I get negative 31.98. So is this spontaneous or not? Negative value means yes. And this was a case where the delta H was not favoring the products. It was an endothermic process. So this one was kind of saying no to the reaction forming products, and the entropy was positive, getting more random. So this one was saying yes. So this was a case where we really did have to calculate it to know whether this could happen at this particular temperature. Another reaction, this is the decomposition of calcium carbonate into calcium oxide and carbon dioxide, and again at 298 Kelvin. So I have the delta H and the delta S, so we'll just calculate this again, and then we can see whether or not this reaction will happen spontaneously on its own. So I put the 178.5 here, 298 Kelvin. Remember to change this, so I'm moving the decimal 3 places to the left. So my Kelvins cancel. So then I have 178.5 minus this term, and I end up with 130.3 kilojoules. So this is positive. Positive, you don't have to put the positive, but the positive is telling us that it's going to be non-spontaneous. This reaction won't happen unless at this particular temperature. If the temperature were high enough, this term would become negative, more negative, and then the reaction could be spontaneous. So this is similar to a reaction we did in lab. I think we took copper carbonate and decomposed it, so we had to stick it into a flame. So the temperature was higher. This is only 25 Celsius, which is room temp. But the question is just simpler, that just to know that it would be non-spontaneous. So I hope that helps.